Hey everybody, this is Larry. This is day 9 of the February Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. I got a haircut in case you're wondering. Thank you for, or whatever. Yeah, so I usually solve these live, so if it's a little bit slow, just fast forward or whatever. Because I usually try to go for my explanation. Okay, so today's problem is convert BST to graded tree. Given the root of it, convert what's a graded tree? Every key is changed to the original key plus the sum of all keys greater than the original key in BST. Okay, let's take a look. Okay, I mean, it's a binary search tree, so the sum of all the keys greater than the original key will be just the sum of the nodes on the right subtree. And then based on that, we could probably play around with the math and from that it should be just a depth first search. That's basically my idea off my head. And yeah, and I mean the tricky thing is that sometimes for these problems you might have to return two things, and I don't think you, I think for this problem you have to return two things, which maybe is a little bit tricky or confusing, but it's not so bad. Oh wait, no, maybe I think I actually misspoken a little bit. Because you have to actually, okay. Oh, I think I'm a little bit wrong, so we can play around with that. But I think the general idea still holds. It's still just depth first search or one of the, probably in order, reverse in order traversal of the tree. If I just process the right root left. So the thing that I misread was, and looking at this example, it clears it up a little bit, is that I thought you have to only look at the subtree of the node. Instead, you want to get everything to the right. So we'll play around with it. But again, like I said, the tricky thing might be that we just have to be careful and making sure that we're passing the right thing. So that's kind of let's get started. I think some version of recursion is what I'm going to do. So let's kind of go for it. Okay, so let's have, I want to say it's in order, but it's kind of reverse in order. I don't know, is there a name for inverse in order? But yeah, and then maybe some kind of current running sum. Maybe I don't need it, but that's my thought right now. If node is none, we just return 0 maybe. And right now we don't know what this returns yet. And for me, it's just about exploring the problem. And as I write the code, I'll know a little bit better. It's not, not every time I would know exactly what I want to write as I get to code, but I'm just kind of feeling it out a little bit. Okay, so right now, okay, given this node, we want to get all the nodes that are bigger than that node, right? So that's everything on the right side of the tree. So we want to get something like this. I don't think that, I think 0 is fine on the right side. Something like that where we want to get the sum of all the nodes, right? So, and again, maybe we'll have two functions or something like that. But yeah, right sum, let's just call it that, is equal to this. And then node.value is equal to node.value plus, or just increment by right sum. Right, and then for the left side we want to pass in node.left and then the node.value which contains all the number that's bigger than it, right? Or the sum of all the numbers bigger than it. So I think, and now we have to incorporate the current back into this thing, which means, let's see. Well, what is the current, right? That means that when we put it in, we want to keep track of all the... So looking at the graph a little bit for visualization, the 1, if we look at the node with the value 1, we want all the nodes that are coming on the top, because everything coming from top, because knowing is the left, it's going to be all the sum, and then also the right node, right? So I think all we have to do is just do this. But yeah, I think that should be okay. And for that reason, going to the right side, we don't return I'm not confident about this yet. I think, to be honest, if I'm doing this on a contest, I would just kind of run this code, kind of see what it visualizes. But let me take an extra second, because going to the right, I don't think you need to ever do anything about it. So yeah, I think that maybe I'm a little bit confident about this. And then the return value will be, what is the return value? We're going to return this, the sum of all the nodes, right? So let's just make that this, right? Sum of all the nodes, or the sum of all the nodes, I guess, nodes value. In this case, we actually forgot something, for me anyway, is that we have to keep track of the left sum as well. That's one case. For example, you look at the number 4, or maybe the number 6. If we look at the number 6, we also need to add 5, because well, I mean, we just need to return it, right? So for that, we can actually do something like, I guess total is equal to the left node plus the current node dot value. Oops, because node dot value is equal to the right sum. Is that right? What is let me think about this for a second. I might have to do something in order. Okay, let's look at it again, because I think maybe I'm conflating something. So let's do it carefully. So total is equal to sum. We add it to the right sum, and then we add it to the node, or we add the node to it, and then we add it to the left. Because I think this current part is the part that I'm a little bit, I don't think you're supposed to pass that in out. So then now we just return total. And then at the very end, we just do an in order from the root 0, and then we return the root, because we don't really need the result. Let's give it a quick spin. I don't know if I've got all the cases. That's the only thing I would worry about. Do I feel okay? I'm missing this 33 apparently. I thought there was a thing where they show you, or maybe that's only in contest mode, where they visualize this response for you. And this is the test case where is the 33? 33 is this node. Oh, I see. So we do need to figure, is this good enough? Passing in the current to the right side. Okay. Yeah, that looks okay. Right, so let's put in more test cases. Still wish the daily problem thing has a test case parser, but yeah, sometimes you know, when you see me do it live, I might not write this thing, but I also find that when I'm having some confusion about what a function should return, and this comes up more often with maybe dynamic programming, or if you have bounds like inclusive bounds or exclusive bounds, or even with these kind of recursive structures, it's good to kind of have a reminder up here so that you know exactly what you want. Yeah. Okay. So this looks good. Let's give it a submit and hope that it is right. Okay, cool. I think this is really tricky. I'm not gonna lie. I think I made this look easier than it is, in how I guess I don't think I did it that quickly, but I don't think I slowed down either. I think the hardest part about this problem is trying to figure out the invariance of what you're trying to do, and then tie it all up into one function. I think you can definitely do this very carefully with maybe 2 functions or something like that are more better defined. But I think if you try to wrap it in one function, sometimes it's a little bit luck, in terms of like whether you see it or not. But basically, once you're able to define this function, and then you could try to figure out how to use it, right? And the reason why I never looked at n, even though maybe I should have, is that all the values are unique. I guess that doesn't. I guess that. Okay, I guess that's fair. I never needed to look at the number of nodes on a tree, and the reason is because I'm going to go do the complexity now, which is that it is in order to traversal of the tree, so therefore it's going to be linear time. In terms of space, it is also going to be linear space, or O of h, where h is the height of the tree, because that's just standard recursion analysis. But yeah, but once you're given the sum of all the nodes value, you look at the, the current node is it's just equal to the current node plus all the nodes to the right, and also all the stuff that's coming from the top, right? I think the hardest part to kind of articulate for me is this current thing, where okay, maybe some top, maybe that's a better variable name, I don't know if it is, but basically this is the top. That is when you go from the top down on the left side. Yeah, and the reason why this you need this is because if you're doing recursion and you're going to the left, everything to that is the parent, and like the rest of the tree is basically you need to sum all of them, and that's basically why I have that the sum top. And once you pass that in, you're able to. So it is a very weird. Because I think the hard part about this problem is that the recursion, it is a recursion that goes in one direction, but you have to, like, I think my code is very short. It's, like 10 lines of critical code, and you could even make the argument that I could probably make this shorter, so I'll consider it short. It's very short, but it does a lot of heavy lifting. There are variables that goes in both directions, one going recursion down and recursion up, and there's a lot of coordination that goes, like, everything is very precise, right? Like, you have to do the right side first, and then you have to do the current side now, and you have to do this is the current side, and then you have to sum it up in a way that doesn't double count the top, and then you do the left side, right? So it's very complicated, it's very difficult, so don't feel so bad if it takes you a long time, because I think I've done a similar problem on a contest or something. I probably took a long time as well, and doing just a funky way. So it's just very lucky to some degree that when you see me do this live, that I'm able to do it relatively shortly. Because I don't think this is a hard problem in terms of rating, but I think it's a tricky problem to get right precisely. So definitely, because you have to really define you have to be really clear about how you define the functions and the order of the functions and how you want to do them. So every line of this, because very often, especially in recursion, or not just in recursion in general, but in Leetcode in Leetcode problems, the one that does stuff with like recursion and trees, very often the order doesn't matter, to be honest. Like, you'll see that you can do it you could do pre-order, you could do in order, you could do post order, you could do it from left to right to left, it doesn't matter, right? Like, very often, as long as you look at every node, it's okay. But in this particular one, everything is very precise, and that's why it's going to be tricky. So if you don't have a great understanding of why everything needs to be exactly where they are, you're going to probably spend a lot of time just like changing order of things or try to understand things, and that's okay. That's how you do the exploration, that's how you do the understanding. But I think that's my comment about this problem, and that if you spend a long time on this, it's probably a worthwhile exercise, and don't feel that bad about it, because I think I could easily see, like, on a different world where I slept not as well, I could spend like 40 minutes on this and I'd be like, why is this wrong, which, there are plenty of videos on that as well. So I think I'm a little bit lucky on timing on this one, but it is a tricky problem, it's a hard problem to get right precisely, so definitely keep practicing and keep on working that out. Cool. That's all I have for this problem. Linear time, linear space, I think I mentioned it, so that's all I have. Have a great night, have a great rest of the week, and stay safe, stay good, stay healthy, and to good mental health, and I'll see you tomorrow. Bye bye.